Hi everyone, and welcome to another AEC+tech Talk. Today we have four amazing designers with us, a super friendly and great group of people. So most of them, I think, know each other, which is great. We're gonna have a casual conversation about game engines and how architects are using them in their workflow and updates on the latest and greatest rendering and visualization tools and solutions. So I'm going to just super briefly introduce our speakers, and then we'll let them talk more about themselves and their work. So we have Shervin Peyghambari, digital experience designer at Co-Architects with us today. Thanks, Shervin, for coming. We have Carlos Navarro, creative technologies at Navarro Studios. Hi, Carlos. Welcome.
Nice meeting you. Happy to
Thank
be here.
you. Thanks so much. So, Matthew Conway, Senior Associate at DLR Group. Hi, Matthew. Welcome. And Kako Peguero, Artist and Educator with United Futures. Hi, Kako. Wonderful to have you.
Glad to be here. Glad to be here with these esteemed guests.
Amazing. Okay, great. So can't wait to hear your stories and see your work. So we can start from Shervin and go with the order that I just introduced you all. So Shervin, Matthew, Carlos, and Kako. So Sherwin, with that, I'll hand it over to you.
Thank you. Thanks for having me. This is great. I've been waiting for this talk to talk to these guys. Most of them I know. I'm just going to show a bunch of projects or showcase a bunch of ways that I've been using game engine, specifically Unreal, in here in architecture. It's going to be mostly me selling Unreal to you because of how powerful it is, but I try to frame it as more of a. Oh wait, is it? Why is it the other way around?
Shervin, before that, can you also tell us a bit about yourself, like your background, where you got, how you got here, like?
Oh sure.
Yeah.
I got here. Let me just put you guys on another screen here. Yes, my background is I'm from Iran. I studied architecture back there and got to start. They asked me to create animation for one competition that they at the office that I was working, and that got me interested in like digital experiences and animations, and I just started pursuing. And then I went to Prague and I studied it more, and then I came to US. I went to UCLA, which actually Matt was teaching there at the time. He was my teacher for Unity. But then I studied like more of like how to use game engines and the use cases, and that got me more interested in that, like moving from animation to anything that can be more interactive. And then I have been working at Co ever since for in the same role, digital experience designer, which is just creating any sort of experiences for the clients for big projects, so they can get a feeling of what they'll be getting. They can invest their money because like it's like $1 billion projects sometimes. Now I've used a lot of softwares to create animations, but the reason I'm going to game engine and like Unreal Engine specifically is how much flexibility it will give me as someone who wants to create an experience, and I maybe in the beginning I don't even know what type of experience I'm going to create, because each project needs something different. But what's cool about Unreal is that once you create the environment, you can present it however you want. You can present it as an interactive walkthrough or an animation using sequences, or make a VR game out of it. I mean, it's not going to be super easy to make VR because you need to optimize it. But at the end of the day, if you have the environment or like the base, you get to choose later how I want to present it. That's what got me interested in it. Now I don't know why I click play. It will this screen becomes the secondary screen for some reason. I don't know how to fix that. If anybody knows, you can tell me, because now you're seeing this side of the screen. Maybe swap. Yes, perfect. This is just general. Yeah, so it's just if you live in LA, you probably know this street. It's like Cedar Sinai, close to Cedar Sinai, and it's an environment that we made with a lot of detail, so we can put our building there and present it, but it's like super believable. This was only used to create still images and not animation. That's why nothing is animated, but like it's staged in a way that's like you can use it for any purpose. And what's interesting for me in this project is the amount of detail I can put in Unreal, and it doesn't mind. I don't know many software that you can just add detail and add more detail and more detail, and it just can handle it. It doesn't crash, it doesn't do anything. Then here's another project, again, using Unreal Engine. And this one, the reason I'm showing it is because, as you remember, I just mentioned that once you create an environment, it doesn't matter how you present it. Now, like this environment is a live environment. People are walking around. There are some interactions between people, like mostly walking and dodging each other, not colliding with each other. But then I am a camera. As you can see, I can just fly around and just be a flying camera, like a drone. But then in the same environment, as soon as I change the player, quote unquote, I get to explore the same environment with the same everything, but as you can see, it's gonna come up as first person. And this first person can actually interact with everything, or like change the time of day. And also, which is another thing that I'm really interested in, I think is the only thing that, at least in our office, can justify spending a lot of time creating a game for a project, is that you can extract information from it. So like this model was created in Revit, and as you know, Revit comes with a lot of metadata. And it's interesting for me that Datasmith just preserves all the information. So not only you can interact with it in like a real world, like opening doors or I don't know, like walking up the stairs or anything. You can also extract information. And on the next slide, I think I have, yes. Just you can see that, like, for example, this column has a lot of metadata, that like who made it, or like what type of family it is. Anything that Revit provides, Datasmith preserves. So you can just click on it, I don't know, a type of tree, and see how many type of that tree of that family you have in your model. I think it will help the clients to just click on it and quickly get an idea of like how many of these chairs do I have in my building. But also, like, that's the interactive and game aspects of Unreal. But Unreal comes also with animation making tools like Sequencer. Whoever has ever used like any type of, like, I don't know, 3ds Max maybe, or Blender, Cinema 4D, you know that in order to create animations, you have to just keyframe stuff and use Sequencer or sequence. Unreal also does have that. Like the thing that I made is super dumb. I just made it to present something in another talk. But the point is that anything that you can change, you can also keyframe and change, which means that as soon as you have the environment, the game environment, you're also ready to create an animation really fast. Like a day worth of job, you get high-end animation even if you have a system, you can use ray tracing to like high quality stuff. But also like this is another this is just a sample environment that I made to show to our office that if you want, I can interact with different objects in the scene, like show different materials for different parts of the building, and create like a game for the client so they can click around. And I have used this once, but that project I cannot show you, so I just didn't. I just showed you the the example project that I made. I don't know how to go to the next slide. It's not moving. Yeah. Another thing about it is that whoever has ever made animations, you know that even if you rig your cars, you still have to keyframe everything, and after a while it becomes annoying. But like in Unreal, there is another extra layer on top of rigging, it's like a skeletal mesh or whatever they call it, a skeletal rig, that you get to assign codes to this rig so that you can activate it. So that pink box is controlling the body of the car. So if you move it forward, it will try to go forward, which initiates the turning of the wheels. And it's animated in a way that you don't have to keyframe everything, and it just responds to the environment. So if there's a bump on the road, it will just respond to it without you having to animate it. I find it fascinating because even if you just want to use Unreal for creating high-end animations, once you have a good asset library of like a bunch of cars and a bunch of people, it will take way less time to get to good quality results than it would in like, I don't know, Blender. And then the full control that you have over sky is like fascinating. It's technically just God mode. You can summon rain and summon, I don't know, thunderstorm by just clicking. And you can even change it in the game, like sandstorm. I'm just going to fast forward to the snow part because I think the snow part is the best part. I think it's great that like even as you can see when I run it, this ball affects the snow, which means that anything that you assign this code to can interact with snow. It's mind-blowing. And then I think this is the last part that I wanted to talk about is the people and how you can have path for people to walk around and they interact with you and with each other, so that you don't have to animate anything. You just tell them where to go. But instead of, I don't know if you've used I don't know, Lumion, they just walk through each other. They don't interact. They don't recognize each other. But in this case, they recognize each other, and there's not just one way to have them walk around. Is you can have them follow targets like this white one. This one is not following any path. It just has random targets that is following. But also, like for me as the player, I can change my avatar with like a click of a button, or anybody else's avatar. And there is also MetaHuman that allows you to just randomize all those people who are walking around. And again, this comes down to this rig that you get it for free from Unreal, and then you get to change the avatar to whatever you want, and it's super smart and interactive. So if you are looking for something like interactive walkthroughs, then I don't think anything can beat Unreal. The only downside that I know of is that you cannot host it on web, and I don't like that part at all. Another thing that's really cool about it is that if you're not familiar with Unreal, I think anybody can use Twinmotion because it's very simple and intuitive. The good thing about Unreal that I used a lot, especially working with landscape architects because they use Twinmotion, is that you can just get their file and export it to Unreal. So if you use Unreal Engine as your master file, you don't have to redo the work of like your landscape designers, because you can just grab it and import it to your file. Saves a lot of time because they spend the time to choose the type of trees on your landscape, and then you just fetch it in. I think it's great. It's a very flawless. Actually, it's not flawless, but it's very fast workflow. Now, This is the last slide I have. This is this was made using Unity, and I don't use Unity a lot. I just want to give it kudos because the apps that you make in Unity can easily be hosted on anywhere, like GitHub. And this is just a phasing, very simple phasing app that we made so we can show the client like what happens over 30 years. And we hosted it on web. As you can see, the graphics are nowhere close to Unreal. I mean, you can get it better. I'm not saying that Unity cannot get there, but we kept it simple so we can host it. And this is another like a simulation. This is like for like a emergency department, like a patient comes in and is accompanied by a nurse to a room, and then the doctor visits. I just showed the first part to prove a point that we can create something like this, but this simulation is actually really long and it has so much to it, which I didn't feel comfortable sharing. But yeah, that's it for me.
Wonderful. Thank you so much. It was super interesting, very interesting projects. Thanks for sharing. So next we have Carlos. Carlos, please tell us about yourself, your work.
Sure. Yes. Let me share my screen. 1 second.
It's the arrow, Carlos, underneath. Did you click on that?
Yes, I think I got it. Can you see my screen now? You see it?
Yes. Yep.
Okay. I'll just present right now. Okay. Yeah, I'll give an overview of a series of projects. Today, I wanted to speak about AI architecture worlds and what is their medium specificity. I'm Carlos Navarro, creative director at Navaro Studios. Have vast experience in architecture and also creative industries, and I've been involved in academia and different and also computer-aided architecture conferences in the recent years. And yes, I'm interested in the medium specificity of these new technologies, specifically last year when Gaussian splatting and NERF appeared in the scene, and all the evolution of generative AI. So I've been working with these technologies for the past years, and my interest is in really analyzing how to use them and what is the best outcome for each of them. I'm going to skip through these so I go to the work quickly. But yeah, my work mainly has been focused on two lines of research. One is just 3D generation and 3D synthesis based on AI, and also world building. I've explored different technologies like 3D GAN, 2.5D, lofting, 3D synthesis, yeah, when NERF and Gaussian splatting appear, and I became aware of this new implicit representation medium, it was sort of a breakthrough to me because of the range of software that I had been using just to develop animation and computational design. In the case of virtual environment or game engines, I work with machine learning-based virtual environments, ML agents, and I've also incorporated these implicit representation technologies into Unreal and Unity. Yeah, so I'm gonna speak in two parts. This first part is basically about how I've integrated this new way of generating 3D models into virtual environments. This was a very one of my first exercise with ML agents. It was a workshop that I ran at Digital Futures, and basically it took the idea of using depth estimation to generate 3D form. At the time, you could already generate images with DALL-E, and this was an exercise of just crafting a new 3D shape using just combining these different workflows, going from image all the way to this explicit representation that you could experience in Unity in this case. So these are just some views of some very early exercises that I did, just like lofting some like disco diffusion images that I generated, and then I
Carlos,
started
sorry to cut
populate.
you off, but I don't think we're seeing those updated slides. I want to make sure that we see the amazing work that you've got.
Oh,
I think we're
are you-
seeing. We're seeing. Yeah, we're not seeing it updated on our end.
Oh, sorry. Let me reshare. Let me share my whole screen then. Entire screen.
If you probably click on full screen, then we can see.
Does that work now? Are you seeing my full screen? Yes, right. Okay. Okay, thank you for that. Yeah, I was just saying, yeah. So this technique that I started from just using depth estimation to generate 3D form and implement it into virtual environments. These are some early exercises that I did at this workshop, and then how I started to use machine learning agents to explore flow simulations of these new of these architectural forms or artifacts. These are a series of exercises in which I'm exploring that sort of flow simulation and this in this kind of architectural artifacts that were AI driven. Some interesting clips of the game environment that we developed using different ways of different representation techniques like elevation and cinematic pannings, just to use architectural representation applied to these game engine environments. There's more exploration that I've done with depth. This is more recent. I used video to video from Runway to generate these weird ecologies that, I mean, they were like, I mean, it was like a very appropriate topic to just generate an interesting video. I mean, it works really well, better than architecture at that time. This is like a year ago. I've been combining different software. Like I've combined game engines with TouchDesigner, bringing in different file formats like Alembic files and things like that. And in this case, for example, I was using open neural networks in Unity to just generate live depth estimation that I could then just transfer to TouchDesigner in real time and just generate this three-dimensional environment. This was kind of a seed project for me that triggered further R&D in this topic. But yeah, you can see how the depth is used there. This is a project that a research that became a paper in Acadia 2023. It's based on 3D neural synthesis using first NERF and then Gaussian splatting. And it was it presented a methodology to recreate, just to use like prior 3D objects and basically 3D capture using different camera methods just to capture a scene, and then using that footage to diffuse it and recreate new 3D form. These are some examples in which, we used a very simple animation of an arch that then we brought into Unity. And the cool thing was that it was brought in a point cloud format that could be enhanced with Unity VFX. So this environment was just like, the experience was just like enhanced by this animation, the animation potential that has VFX in Unity. More exercises with 3D synthesis, using video to video to generate, in this case, Gaussian splatting. This was the first time in which I generated this sort of let's call it 4D architecture. I mean, really, it existed in time, and it was a three-dimensional object that was created from video to video. And then, just ways of implementing this. This is like just like a test of how to implement ML agents into that building. I'm just gonna skip through that. So this second part is, in these projects, I've explored large language models for storytelling and also for interactive worlds. I'm interested in embodiment and simulation. What's going on here? I've explored MetaHuman with Unreal, and I'm interested into just different ways in which language can be applied for interaction with the 3D environment. In this case, I was just curious about speaking in another language, so I used OpenAI and NVIDIA Omniverse just to recreate this haiku in a hyper-realistic rendering style. And then I was also very interested in using the 3D reconstruction technology of Gaussian splatting and the animation potential that Unreal had. This is the first time that I animated a Gaussian splat in Unreal using Niagara and different methods for just to enhance the effects with turbulence and curve forces and methods like that. Then comes this one, Zero Carbon Futures, an AI-driven participatory design platform. It's a project that it's on view right now at the Venice Biennale, and I was the Unity developer for this project. It basically involved an exploration into 3D reconstruction using point cloud and also Gaussian splatting, and how could this be used for architectural representation and animation. So usually splats in Unity are very static, as opposed to Unreal. So this was an exploration in which just using like shader methods, I was able to obtain an animation for these 3D reconstructions. And most of it was using the same techniques as before. We used video to video. First, we took a drone photogrammetry of a building, and then we used those videos and applied video to video with Sora, and also used depth estimation to generate point clouds, as you can see in these images. so that the videos would have three-dimensional qualities. And then these ML agents were used to assess the redesigns that we had come up with from the reconstruction survey. So yeah, you can see here some of the. Sorry, that one is not playing, but yeah, the drone photogrammetry animated with Gaussian splatting and ML agents performing flow simulation inside a building, and then the building evolving into new architectural designs for public space and also facade design. And we tried different design options. It was all based on Sora, and again using depth estimation to generate to provide three-dimensional qualities to these 3D objects. Yeah, some screenshots of these, and then some of the interaction that I developed. Yeah, I integrated the OpenAI API to make these agents interact with natural language. These are some interior shots, and yeah, just like aerial views of the flow simulation. These are very these are initial states of just like trying different avatars using the same rigging, but just like interchanging avatars to populate this scene. This is the one on the right hand side is the agents circulating the building using the Cesium plugin in Unity. Before that, we had the photogrammetry model. We used this 3D mesh provided by Cesium, and it worked really, really well, actually. This is a little bit of a snapshot of the interaction. Basically, this is the script in which you give a series of instructions to the API, and then you establish a system and a user. And then I came up with word information, NPC information for each of the agents. And then the script would pick up information from this, from this buckets of information that I set up. And then the agents would assess. They would make a qualitative assessment of beauty, safety, greenness, and walkability and comfort. So you can see now some of these in action. Oh, let's see. Let me share again. Okay, yeah. Let it display for some seconds.
Wonderful. Thank you. Thank you so much, Carlos. Can you guys hear me?
Yes.
Oh, okay, perfect. Thanks so much for sharing. What beautiful, eye-catching, stunning visuals.
Yeah, and let me just show one more. This is one that I just wanted to show before I finished. This is a current research that I've been doing. It's a mixed reality installation that involves generative AI in real time for virtual environments. It works both with Unreal and Unity, leveraging TouchDesigner for generative AI inference. And it's based on capturing the world with 360 cameras that you can implement in both engines. And basically, you can inhabit three-dimensional DOM environment, leveraging depth, and having AI inference working in real time. Of course, this is limited by your graphics cards, but again, the interesting part is that you can also leverage large language models. Again, you can set up a system and a user and a series of instructions for the system and the user, and then create a sort of a current world state with information that you provide, and then trigger some events that you set up yourself. In this case, I'm using MediaPipe to just control these triggers with the pinch of my hands, and then having results events that would update the world every time, and then the narrative would loop. So this is this, yeah.
Amazing. Wonderful. Thank you, Carlos. Thanks for sharing all this amazing work with us. Beautiful. So is this your last slide?
Yeah.
Okay, wonderful. Thanks a lot. So we'll get back to you with some questions. So next we have Matt. Matt, please feel free to.
Hi, everyone. I'm a licensed architect in Texas and California. I went to grad school with Kako. As Shervin mentioned, let me see if my screen's working. Video doesn't seem to be loading. You're seeing a white screen, right?
Yes.
Yeah. Okay, cool. As Shervin mentioned, I used to teach at UCLA, taught Unity there, mostly for simulation purposes. And I feel like I might, I know Caco's work a little bit, so I imagine I might be the only one on this call where our team uses game engines not for their graphic quality. In practice at DLR Group, I'm the computational design leader, and we use Unreal Engine predominantly. And there's a team of us, so this is not just all me. There's 6 of us in total, and there's 3.5 of us that I would say use C++ programming. We've moved away from blueprints predominantly because for versioning, keeping track of things, it's a little bit easier. We found that blueprints have some issues just knowing what's been changed. This is the first project. I'm going to show 4 projects. This is the first one called Design Review. And it's not a super complicated project. It's, Shervin mentioned Datasmith. We're importing our Revit models from Datasmith. And this was really a project, about being able to collaboratively view and spread out office. There are 3 offices within the States. And not only that, so we can collaboratively view, be in this space, adding tags. That's sort of what you're seeing here. We also have a lot of stakeholders. Our predominant sector is schools, and our other big sectors are institutional. So we have a lot of clients who we like to just send links to this to. They can view it in our, with our designers kind of leading them. A lot of these stakeholders don't have comfort navigating 3D space. So this allows us to sort of share that and be more collaborative. The next project we've used Unreal Engine for is for our healthcare clients. They like to be able to preview the space that's been made. And the reason we've done this in Unreal Engine is that we have, they need to be able to interact and see if they can actually use the space. So this is actually a VR application where they can go, they can move things around. There's this, there's a lot of work into getting these different medical arms to swivel properly. So that they could test if what they're going to need to use the space for actually works. And then obviously this is correlated with data coming from Revit. So that was really important to be able to use Unreal Engine for that purpose. The next, so you can see this is them, moving around. The next project we've been using Unreal Engine for is we have a really robust reality capture team where they go out, they scan a site, and then they rebuild that site in Revit. We found that Unreal Engine's really great for viewing point clouds. And then we've also been working, we have a data science team that works in tandem with us. That's also, I think it's 5 people right now. And we have a model that can take that point cloud data and turn it into geometry, which then we can import into Revit as like walls, floors, ceilings, that sort of thing. So here you can see what we're showing here is that model's been run, and they're using Unreal Engine to preview how those walls match up to that point cloud data. And then the most recent update to this project, and the videos I'm showing you, by the way, these are all internal enterprise level tools. These videos are what our team uses to communicate and show our ideas to different people within the firm. The current update we've had added to this is that they can then manipulate these walls once the point cloud has been like processed. So this is giving them the ability to do this outside of Revit. It's a little bit quicker. There's like certain snapping properties we've been able to add. They can view it. They can, it's a little bit lighter of a model too, because we've reduced it. So this is before they go into Revit. And there's a process that can take whatever they've done in here and bring it into Revit. And then the last thing, the last project, I have 2 slides for this project. This is the one I'm the most excited about, is we're developing a tool that we're calling space programming. Like I mentioned, a big sector of ours is schools, and there's always a lot of program that goes into school, and they're very non-normative layouts, where like office buildings, housing, there's certain things that work for those type of layouts, but schools, no 2 schools look the same. There's not really like a very consistent way to lay those out. So we've worked on and this is built on top of that design review platform I showed at the very beginning, with the idea that collaboratively and potentially with a client viewing, you can take those program sheets and bring them into this program. And then there's certain, like you're seeing some snapping things happening. You can bring these together and more quickly and collaboratively just like build that space program out, see how it would work in the school. And part of the reason we're doing, and like I said, this one's the one under development. I'm excited about it because I like this idea of currently in Revit or even Rhino, we're predominantly modeling like with like an object assembly based thought process, where we use a lot of data that's room based. And so I like this idea that we're modeling with the space first, and that will then generate the walls, what furniture is required in these different spaces, that sort of thing. So it's a different way to think about modeling. I think much more in flow with how we currently design buildings. So this is an earlier preview of that. And I have one more video of this one. This is a slightly more recent video showing, just pulling in context from like OSM data. So that we have a planning group also. So this kind of site context tends to be kind of important. And then this again can take this, and then we have a script that then processes it into, it's just a JSON file that then we can import into Revit and turn, where those walls meet, it'll turn that into a wall. I mentioned a lot of our decisions are based on like room information. So like, knowing what walls are adjacent to what walls, we can change, fire ratings, sound ratings, these sort of things. So to me, this is like one of the more exciting projects that we're working on. I'm hoping that it sort of changes how we design. We're currently working on, you see right now, this is just dumping all the blocks in. We're currently working on adding other additional features as far as like being able to quickly align, group things, because laying out like 200 rooms is still, even with this snapping system, is still kind of tedious. I'm sure plenty of us have done this in Rhino before. So yeah, that's what, like I said, that's what we're working on currently at DLR Group. So hopefully looking forward to this discussion that we're about to have.
Great. Thanks so much, Matt. Thanks for sharing. Great work. So you said some of these are the internal tools you've been developing, right?
They're all internal enterprise tools. So this is not a sales pitch.
No, yeah, I was just curious, like when do you guys decide to build these internal tools? Is it, why? Is it for like data privacy issues or like?
I mentioned like we do a lot of institutional stuff. So data privacy recently has been really big. We have other tools I'm not showing as far as like we have our own internal AI rendering and in our own internal LLMs because of a lot of government contracts have really strict data privacy. So that's one reason. The other reason is just a little bit more control and making it fit into our workflow, how we work. And also like, there's also a certain ROI where sometimes, tools are never free and they cost money. And sometimes it's not only do we have our own control, we can fit into our workflow, but it might be cheaper to develop that tool than continuously pay someone else for it. And then, we saw this recent thing happen with Cove tool, right? Where like they had this tool, it was kind of exciting. And then all of a sudden they came out that, oh, we're also an architecture firm, by the way. Yeah. We provide services. And that causes all sorts of issues to potentially pop up, right? And so there's also just something with not just the control of like how the tool functions and fits, but also just like down the line, we're trying to think long-term with these tools. So
makes sense.
All those and probably some more that I'm forgetting.
Okay, wonderful. Thank you, Matt. So Kako, you're next.
Fantastic. I think that the building your own tools is a really great approach, and like it seems like Carlos and Shervin also like build your own things for your own use cases. So really, it's really cool to see everybody's different approach. So thank you for having me. I'm excited to be on this panel with all these esteemed guests. My approach is going to be maybe a little bit different. My name is Kako Peguero. I'm an artist educator. I wanted to give a little bit of a background into like how I got into this. As Matt mentioned, we met in grad school. I also have a background in architecture, which is probably why I got invited to this panel as well, which makes sense. So my presentation will be about like how I got into like architecture and tech, and then like how I use it now, and then like hopefully we can have conversations about like where we think the industry is going and these tools are going. So first I'm going to start off with like how I got started doing these kinds of things. And for me, it started in grad school where I had my thesis on augmented reality and architecture. So asking questions around the interaction with media. So it's like we all watch movies, they make us feel something. We all listen to music, they make us feel something. We all go to like buildings, and they also make us feel something. My thesis speculated on the role that digital architecture can play in human development, and it was super speculative and like human evolution. It's like, can we use digital architecture to evolve humans in like maybe in a direction? So visually integrated spatial experiences where you had a blend of both physical and digital was what I was speculating. Asking the question, does architecture have to manifest itself physically to have an effect on the way we engage with it or our environments? Famous paper architects, Ledoux, Lebbeus Woods. So there's a history of architects representing buildings, environments that then have an effect on sort of the industry as a whole. So that's sort of my where I sit in this like representation. So I think about architecture and interaction and information a lot. That's like what I do, and I use game engines for extended reality. The types of projects that I work on are sometimes they're art clients, so actual realities at the Serpentine Gallery, where the Serpentine Gallery was rigged using 3D modeling software, and through an augmented reality app, you can engage with the building in a different way. So going back to like the interaction aspect of the architecture, both like physical and digital.
Kako, sorry to interrupt. Do you mind going clicking on the slideshow so we can see your full screen?
Y'all want to see it full screen all the way?
Yeah, that'd be great. So
is that better?
We don't see it.
We can't.
You don't see it here. Let me try this again, because I just shared. Let me share my whole window. Let's try this again.
Okay.
So.
Yeah, sorry about that. Yeah, because we have some like really great.
That's okay. They are beautiful slides. I appreciate it. Thank you. Thank you for recognizing. Share window. Share. Here we go. All right. Let me know when you can see.
Yes, we can see it now. Perfect.
Cool. So other projects that I work on. So Pierre Huyg's variants, where an entire island was scanned using point clouds, I created a series of 3D models that were in the space and also sort of alive in the space. So creating generative creatures that responded to real world conditions and then like had their own experience within the environment. Most recently at the Venice Biennale, I worked with artist Wang Shui to create a video installation where the video responded to how people were engaging with the sculpture. The sculpture was an LED screen that they had woven together. I responded to barometric pressure, density, and sound. So as like people looked around the space, the sort of agents within the simulation would change what it was that you were looking at. Also created a augmented reality zoo for extinct animals using this was also in Unity, so users could walk around the space and engage with the different animals and then learn about them and like how they became extinct essentially. So I guess this really begs the question is like we've seen um, Unreal, we've seen Unity, we've seen it used in a lot of different ways. And I'm gonna put my educator hat on, artist educator, and hopefully define like what is a game engine, like what are we talking about here when we say game engine? Because we're familiar with game engines such as like we can throw that word around and we know like Unity's a game engine, that's great, but why? Unreal also a game engine. But what makes it a game engine? So a game engine has a couple of components, and I think it's important for your viewers to understand, like, this is what makes a game engine. You can render, it has physics, it's got audio, input management, and scripting system. I think that, like, and there have been comments by, like, famous developers, Notch, being like, if you don't build your own game engine, you're not a real developer, blah, 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 wherever that sits. A lot of us still like use like these existing game engines like Unity and Unreal, but other programs that also have this this list of things are TikTok and Effect House. So I also teach at university. I teach a technology course at UCLA. Carlos, I'll probably be seeing you later at the final review.
Yes.
But we used TikTok to build social filters where the students could use the augmented reality features and bring those objects to life. So it's like we've seen, I also wanted to show like you can engage with these tools in game engines and you probably are engaging with them in ways that you don't even realize. So it's like there are ways to get started that maybe don't seem so so technically heavy or like require so much technical overhead. So it's like lowering the barrier to entry maybe a little bit. Other classes I've taught are representational. So this one's at Woodbury, where students used Unreal Engine to build a narrative and explain what are their existing projects. And then also another one at Woodbury where a student used virtual reality to visit the interior of a religious site. So it's like something that they feel like they would never do and wanted to share that information. So I think there's a lot of potential in game engines, whatever platform that they manifest themselves, to use in like experience, representation, interaction. So thank you for having me, and I'm excited to have this chat.
Wonderful. Thank you so much. Thanks for sharing all this great work and your past projects and your vision and your research and all that. So I was actually hoping that we can have like a longer time for discussion, but all your works and projects were so amazing and eye-catching that that really represented, you know, your thinking and your work on the current and a little bit of the future of this rendering and visualization in AEC, and especially for architects. So we have 6 more minutes. And I have a lot of questions, but if any of you have any specific question, actually we have one question from the audience. So Rohit is asking, Shervin, what mouse are you using to navigate the flythrough? This is a very technical, you know, specific question. So okay, that's your mouse. Great. Yeah, so maybe for a few minutes we can talk about so some of these tools and software and solutions. And so Matt mentioned that you guys build like internal solutions, and you all talked about like Unreal and all these engines. So similarities, differences. So maybe we can talk a little bit about the software and solutions that you choose, what your process is, what the thinking is behind it, and then how important it is really. I don't know, some of you that you're teaching maybe at school about that. So software and solutions and tools, and then the future. So we see more and more AI powered rendering platforms and collaborative solutions. So how do you see the future? Do you think it's going to be revolutionized soon with AI? Or so back like 4 years ago when I was practicing as an architect, we used to use Lumion. Lumion was our go-to tool for rendering. So maybe if you can each talk a few minutes about that. Again, we only have now like 4 minutes. Oh my God, I talked for 2 minutes. Okay, I didn't mean to do that. Okay, maybe if you can, it's okay if you all have time. We can go over the time, maybe five more minutes. We can discuss this.
Sure.
Oh yeah. So whoever wants to volunteer.
So I'm just gonna jump in because I like Matt mentioned artificial intelligence, like having their own custom LLM models. Carlos does extensive work in like AI generative systems. I didn't talk about any of the AI stuff that I do, but I also teach artificial intelligence, and I think that all of our backgrounds are in architecture, but we have picked up these tools like within our professional career. I'm just gonna throw it out there. It's like my guess is that we all vibe code in some capacity, just because like programming has become really it feels like cheating, but it makes things happen a lot faster, which is, I think, when you're working, it's like it's great. It's great when you have these tools that are coming up and you can just like start jumping in. I think that like even Shervin is like background in architecture, like jumping into like these technologies. It only helps you to know and engage with them, and I could definitely see, but we're all using it in like our own specific way. So I think that like there's a lot of room for building your own tools, or like using the tools that exist in your own like arena or interests.
Absolutely. Thank you.
We are not vibe coding. I want to.
No, well, it's because you know how to code. That's why.
Yeah. Everyone on our team learned coding before the LLMs came out. But there's also other like similar to like we can't use certain, like we're not allowed to use Midjourney.
True.
There's like certain things we just, because of the corporate nature of how we practice, we can't use certain things. I like this question of like, how do we choose tools? And I wanted to point, I mentioned I taught Unity before, and I still, when I have to teach game engines, I use Unity for that, just because I think it's a little bit easier for students to get into. There's like the language is similar to language in either Revit or Rhino. By that, I mean like C#. And setup, I think, is a little bit easier, where Unreal Engine, C++ is just like another beast, I think, for students that are just usually new to coding in general. And I think also the lightweight nature of Unity helps a little bit. It's like easier to host. Shervin mentioned hosting stuff online. So I think it's really great for that. It's successful. I know Kako uses Unity too when you teach. I don't know if you use both, Kako, but
I use both, but it depends on exactly like the lightweight nature of it is definitely a draw for like people who are just like dipping their toes into it.
Yeah. And I liked, Kako, you brought up like what is a game engine and like why do we even use these things? And like my hope for the future, or in the direction I see it going, is like I hope that, like I said, I think coding is going to become more and more accessible. I think vibe coding is like maybe I'm hesitant to see if that's going to help or hurt that, like the long-term coding.
Yeah.
But for now, it seems like it's making it more accessible. And so I just see there being more and more software and becoming easier to build software. So my hope is that like we'll have slightly more custom engines, that maybe are built into, like, for instance, right now, our team also does stuff in Revit and Grasshopper, like a lot of, I'm sure, computational design teams do, but we've tried to move a lot of our geometry algorithms to like a standalone backend assembly. So like we can just reference the same thing. So like we're building a geometry library. And I know, like, if you look at Zahat's tech stack, they have like a really robust geometry library they've built out themselves. And Gary obviously has a digital project that has similar parts to it. So my hope would be that increases. I don't know. I think people I've noticed in the field are becoming sort of tech exhausted in a way. So I don't know what that means for computational design, but in practice, it seems to be a thing that's happening. So I don't know.
Arts and crafts movement, maybe.
Yeah.
I have a question for Matt. How come you're using Unreal to create that app? It seems like you're not using Unreal for its graphical capabilities, but like then you're using C++, like.
I think so we started these apps, some of them, like that design review app is like 2 years old. And part of it is like, even though we're not using the graphic abilities, Unreal still has I think is more powerful than Unity in certain ways. And I think for scalability, we chose Unreal. And there's also, you mentioned the Datasmith Twin Motion, right? Twin Motions are, ever since it became free with a Revit license, right? Twin Motions are go-to in-house rendering platform. And so the fact that our design teams can just set up their models in there and we can bring that into whatever application we have for Unreal is also very helpful. So I think it's like, that's a big reason, another big reason for Unreal.
Yeah, I was just gonna comment the same, because I was really impressed. I mean, it's like, because it's sort of generative design that you usually do in other software. But yeah, I just think I can imagine the potential that you can have with that kind of tool. I mean, it speeds up design really, really fast. Yeah.
But Matt, why even bother with Unreal if y'all are doing it in C++? Like, why aren't you just building your own standalone
application?
Yeah.
I mean, we'd have to. There's other things we would have to get
Yeah.
our own rendering system.
Yeah.
There's certain like hosting it. There's certain things that Unreal has already packaged and built in. Like I said, maybe in 10 years, maybe.
Yeah.
I would love that. But right now, Unreal has a lot.
Because I feel like what I'm seeing across these different projects and products is that we're all building our custom software within these game engines. And calling it a game engine is kind of like, it feels like it doesn't really explain the potential in a way, where it's like, you can do games, you can do simulations, you can do visualization, you can use it as like a prototyping tool. So it's like, that's why I thought it was important to show. It's like you need rendering, you need lighting, you need physics, you need interaction, audio, animation. But like that can be anything, really.
Yeah. I mean, I think you're right. We use it as like a dev environment that's already has a lot of things set up for us. I talked to, I used to be in Los Angeles with all these fine people, but I recently moved to the Bay. And from talking with a lot of programs up here, this idea of like, how low do you go? Even then, they're like, oh, C# Python. They're like, that's too high level language. Like, you got to go.
Yeah, you got
to go lower.
C.
Yeah. They're like just straight machine code. So, yeah. So I think that's always a question of like, at what entry point do we get into that? And like I said, I think you're right. Kako calling them game engines might be doing a disservice to like what I consider a just preset up dev environment.
Yeah. And I guess not to like scare people away, but about all this tech, if they're trying to get into it, and like doing this stuff for a while, and then hearing other developers talk, and I guess I'm speaking kind of on the creative side, most indie developers will be like, yeah, like how it looks and like what it does is going to be more important than like like if your code is perfect. That being said, you still want to be really organized with everything. Like if you can do it, like, because that'll just help you in the future. But like, yeah, like what it looks like and what it does is at the end the most important thing.
Yep, definitely. Awesome. Thank you so much. So, I was just going to say that, on AEC+tech, we have this case study library where you can share your projects and your case studies with us. So it'd be great if you guys can share any of these projects on the platform. So the idea is showcasing the applications of these tools and technologies in the real world and showing how they are solving real world problems. So if any of you can share any of these projects with us on AEC+tech, it'd be amazing, because then we can share it with our wider audience, and then they can see what tools you are using in your workflow and how it's helping you. So thank you all so very much. This was a great conversation. Thanks for sharing your knowledge and your beautiful projects with us. This was great. So do you have any final comment, final thoughts? We have to wrap up probably maybe in a minute. So
I would say if you have any questions after the presentation and you want to reach out, feel free to reach out on whatever platform, Instagram, LinkedIn, email. Happy to continue this conversation.
yes.
Yeah, thank you for the invitation. It was a great session.
Of course. Thanks for joining. Have a wonderful rest of your day and have a great weekend. And looking forward to the next one.